Well, good morning, everybody, or good evening, I should say. Welcome to today's webinar. It's one of two virtual events that we are holding, during which we'll talk to you about Direct, which is a new class of software to power the next generation of faster, wider, higher resolution digital presses, and is the first fully integrated product line from Global Graphics Software. I'm going to hand over to Ian Bolton in a moment, who is the product manager for Direct. But I'd just like to advise you that this webinar is being recorded. And at the moment, your microphones are on mute. But if you do wish to ask a question, please use the Q&A function, and we'll make sure that we cover all your questions at the end. So without further ado, I'll hand over to Ian.
Hi everyone, I'm Ian Bolton, and today I will be presenting to you the product launch for Direct, a new class of digital print software. Before we begin, I just need to clarify how we'd like to handle questions. Rather than answer them throughout and potentially get off track with the timing, we'd prefer it if you could type them into the chat box or via the Q&A feature of Zoom, and then we will answer them at the end. We really appreciate that, and of course, your attendance. All right, let's get started. Who am I and why am I here? I'm going to resist the urge to get deep and philosophical here and just introduce myself, as I don't believe I've met many of you before. And one of the reasons for that is that I've not actually been the product manager for Direct for long. As you can see there, I only started in February and I haven't been at Global Graphics for long either. So when I joined Global Graphics last June, I was hired to work on the Direct team as software developer in test. That was initially to bring up the continuous integration and then automate all the testing for Direct. Using that test infrastructure, I was then able to do performance runs for tuning and to determine if we could meet customer requirements for specific jobs. Clearly it all went well because here I am today launching it. Before Global Graphics, I did my undergraduate degree in computer science at the University of Manchester and then a master's there as well in advanced computer science. Aside from some time working as a games designer, my career has involved over 15 years in industry, focusing on performance and optimization. I worked on many architectures at a low level, trying to get the best out of them. So you can see there x86, MIPS, PowerPC, the ill-fated Titanium, 64-bit version of x86, and ARM. Most of that was doing dynamic binary translation, a kind of emulation where performance is key because you're translating at runtime. One customer used this to move their existing PowerPC ecosystem over to Intel without recompiling any binaries. The last one there, ARM, I worked there for 4 years on compilers, both 32-bit and the 64-bit one before it launched. So throughout that time, CPU performance has improved dramatically. First, clock speed in accordance with Moore's law, and then more recently with parallelism, adding lots and lots more cores. And it was this interest in high performance that first attracted me to working on Direct. And it's also one of the reasons I'm really excited to share it with you today. So without further ado, it's time to get direct. Yes, today I'm here to talk to you about Direct, a new class of software to power the next generation of faster, wider, high-resolution digital presses. This really is a game changer for the digital print market, and I'm looking forward to showing you why. To do that, we'll start by examining the key market driver for Direct, which we call the data rate barrier. It's this barrier that is showing the limits of traditional print software built around disk technology. We'll then show you how Direct smashes through this barrier to unlock the potential of your digital press by driving jobs directly to the printhead electronics for unprecedented speed and image quality. We'll also explain why Global Graphics and our sister companies are uniquely placed to deliver this innovation with our first fully integrated product line. So let's start with this key market driver, the data rate barrier. Each of the following requirements multiplies the data rate barrier required to drive a press. And this first one is huge: fully variable data. Now that digital presses have established themselves as capable and worthy successors to traditional presses, We're into a new era where we really can take advantage of the new opportunities that digital provides. The main one being that without requiring plates to be made, it really is possible for every single page to be different. This is a whole new level of challenge compared to traditional variable data in the form of barcodes and text, where it's possible to reduce the required data rate through caching any static parts, for example. But regardless of the type of data, another trend is that OEMs are moving to higher resolution heads. A move from 600 to 1200 dpi quadruples the data rate by itself. OEMs are also requiring faster line speeds, so we're seeing up to 1,000 feet per minute. They're requiring wider presses with single pass alternatives to traditionally multi-pass presses. There's increases with extended gamut, so that's like adding orange, green, violet or white or varnish with a need to support additional print bars. Then there's multi-drop and multi-level screens for much higher quality, again increasing data. The result is the data rate is becoming a technical barrier. Let's see what kinds of data rates we're really talking about here. So this table has been created using the data rate calculator you can reach via our blog, and the link's down the bottom there. I won't talk through all the numbers, but the main point is that even the narrow web 4-color press requires a data rate almost twice as fast as an SSD can manage. And that's based on having a 500 megabyte per second read speed, which is the fastest they can achieve at the moment. And obviously writing will be slower than that. So we won't go through all of these, but let's just look at the publication press. So 200 meters per minute or 650 feet, 1 meter wide, 42 inches, 4 colors, 1200 by 600 dpi, 30 gigabytes a second, which is 60 times faster than, or more data than an SSD can manage. So even with one SSD per color, you're still looking at 15 times faster than the disk can keep up with. So now we've established why we'd like to break through the data rate barrier, it's time to consider how it might be done. For this, I'd like to use an analogy of breaking through the sound barrier. So on the left here, we have the XF-84H Thunder Screech, the fastest aircraft ever fitted with an operating propeller. It hit 623 miles an hour, or 1,000 kilometers an hour, and represents the pinnacle for that engineering approach. But it was only Mach 0.83. Breaking through the sound barrier would require a new engine. So in the printing world, this is analogous to the disk-based solutions originally designed for traditional print. So breaking through the data rate barrier is going to require a new software engine. Back to our images now. In the middle here, we have Chuck Yeager in front of the Bal X-1, the first aircraft to break the sound barrier in level flight. They used a rocket engine to get there. It really was rocket science. It involved huge engineering teams, resources, and constrained environments. This is analogous to the tier 1 print vendors with large dedicated software teams and dedicated specialist engines that have been developed in-house. And our core technologies are used to drive the fastest of these presses. But investing time and money in this kind of software engineering effort is not something everyone can do. They may not even have the expertise for it. So back to the sound barrier again now. Further development was required to get a supersonic flight-capable engine at the right price point widely adopted. This was achieved by developing the jet engine, and we now see planes that can routinely break the sound barrier, such as the F-15 over here on the right. So this is analogous to Direct. It is the first software print engine that can break the data rate barrier and be widely adopted. We will now see how that's achieved. So the first design decision for a direct engine has to be ditching the disk. Even with the fastest solid-state drives available, you don't have enough speed for the kinds of data rates we talked about earlier, since traditional workflows have to read and write data many times. While disks are great for storing your input PDF or other big data, there's really no place for them in the middle of a pipeline where you want to send the screened output direct to the press electronics as fast as possible. Aside from the speed gains for driving the press at the rates you want, there's also the convenience of being able to start printing as soon as you have the input files. However, going direct involves more than just ditching the disk. Let's look now at what goes into creating a direct engine. So we've already covered why we don't want to read or write to disk, but what else? Well, you have to have the fastest components. So for your software, your RIP and your screener better not let you down. Ideally, they're the fastest in the world. You need powerful PCs. If you're building a software-only solution, your performance improves as PC performance improves. As we saw earlier, it is always steadily improving. So you want to be using the best CPUs and fastest RAM. And of course, networking between PCs and the press, that doesn't want to be a bottleneck either. You also need to be predictable across jobs. It's one thing to be the fastest in a controlled environment, but once widely adopted, you can face huge variations in job complexity. You need to know what speed your press will be able to run at. Press shops especially need this to plan their schedules and how many jobs they can get through. You also want tight integration with the press for automation, for feedback if there are any errors, for example. So we know the requirements, but what speed should we aim for? Well, rather than aim to just be the fastest available, which might be enough for today or tomorrow, you have to target the most demanding challenge, ultra-high data rates, to support fully variable data on the fastest, widest, high-resolution presses with extended gamut and multi-level screening. You can then scale back the specification and cost of PCs to handle less demanding scenarios. So lower DPI or not fully variable data, static or mixed static and variable data like barcodes and so on. I think it's now time to unveil our product range. There are 3 products in the direct product range: ScreenPro Direct, Harlequin Direct, and Streamline Direct. Which products you need to smash through the data rate barrier will depend on your workflows and existing technology investment. Let's take a look at that now. Whilst many of you will be familiar with some of our core technologies and could already be working with them, what we're focusing on today is the top row, the direct solution for printer manufacturers. We have 3 products tailored to your input sources that form an integrated graphics pipeline to drive the press directly at ultra-high data rates. It's so fast because we built it from our core technologies, already the fastest and highest quality components, with complete access to the source code and no dependency on any third party. This is tight and optimized integration. Global Graphics has a 30-year track record of innovation, tackling the hardest engineering challenges in digital printing. So what we've created is pretty fantastic. I'd like to now go into each product in detail, moving from right to left, starting with ScreenPro Direct. So whilst we said at the outset that Direct enables you to ditch the disk, we appreciate this isn't going to happen overnight, and for some situations, it is fine to rip in advance. In fact, a number of our customers do this because it fits their workflow, and they are already using ScreenPro Direct to screen directly to the electronics at ultra-high data rates. For static jobs or mixed static and variable data, this may be all you need because not every screen page will have needed its own unique input to have been ripped in advance. Whether it's thousands of copies of the same book on demand or labels that are generally the same but with unique tracking codes, for example, the input data will not be huge and can be waiting for you to screen it predictably to the press at the ultra-high data rate you require. Let's have a peek inside the architecture now to see how these ultra-high data rates are achieved. There's 2 main things I want to highlight here. So you have multiple ScreenPros in parallel, which is configurable. So there it shows 3, but it could be up to 14, 16 even. And the other thing is that you're streaming output directly to the hardware. You're not writing to a file on disk. As with screening, the number of packing threads, which take the screen data and output it in a form that the electronics requires, is also configurable. On the left, I should point out that the input does not have to be via shared memory, but that is faster than disk, as we already established. So if your RIP isn't set up to output to shared memory, then you will need to RIP ahead. I also like to highlight that print flat is included here to take your quality output to the next level. Let's now see a summary of all features and benefits of ScreenPro Direct, the ultra-high data rate half-tone screening solution. It's multi-core and multiple PC and can be configured in many ways. You can run all colors on a single PC, one color per PC, a group of colors across an arrangement of PCs. The ScreenPro Direct pipeline is also very configurable, allowing you to tune how many threads each plugin in the pipeline is allowed. Configuring the number of threads allocated to ScreenPro Direct can also allow multiple programs to run on the same PC simultaneously. For example, drivers for electronics or third-party RIPs. You can start printing as soon as you have continuous tone images from your RIP of choice. Configure your RIP to output continuous tone pre-separated images to disk, and once you've created all the images you need for a print run, you can complete the screening and streaming on the fly whilst the printer is running. The speed at which the rasters can be screened is predictable and deterministic. It doesn't matter what content the image files contain, ScreenPro Direct will process them all at the same speed. Whilst we can drive Meteor inkjet electronics out of the box, ScreenPro Direct has been designed to drive any electronics. We've already built plugins for a number of other industry standard electronics. Our technical services team can link to new hardware very quickly, and it typically requires a 20-day breakthrough service. Our breakthrough projects are recoverable against licenses as soon as you start shipping and are therefore effectively free. As part of this, we've done specialized plugins such as supporting bar splitting or supporting an inspection system for checking output quality. As we saw on the previous slide, ScreenPro Direct includes our award-winning print flat, and you also have that option to use a custom screen design service for taking your output quality to the next level. If you're using Meteor electronics, then mix mode can send static data to the preload buffers for each of the static bars at the beginning of the run, e.g. cyan, yellow, and magenta. It can then send just the variable data regions to the channel driving the variable data print bar, e.g. black. In many cases, this will reduce the PC part of the bill of materials for the printer while still driving at full speed. Also, if you're using Meteor, you have access to Nozzle Fix, which provides nozzle out compensation for single pass or scanning systems to eliminate single pixel streaks from clogged or failed nozzles. Deviated or missing nozzles are identified to the Meteor data path and switched off, while nearby nozzles apply compensating fluid in the same or different color planes, resulting in seamless correction. ScreenPro Direct is cross-platform with Windows 10, IoT, and Linux, so that's Ubuntu and CentOS currently supported. And adding ScreenPro Direct into a solution is an ideal stepping stone to Harlequin Direct. Once you've connected your printer electronics to ScreenPro Direct, it will work with Harlequin Direct. Speaking of which, here we have Harlequin Direct, which gives you all the benefits of ScreenPro Direct and lets you start with PDFs, and then rip, screen, and stream them direct to the device at ultra-high data rates. It's this that enables Harlequin Direct to smash through the data rate barrier to support faster, wider, and higher resolution printers and fully personalized jobs where every page could be unique within a production run. Let's look at what Harlequin Direct looks like for a single color bar. So we start with a press-ready PDF, which is then ripped to continuous tone. Here you can see 4 parallel farm rips, each ripping a different page or item. Each of those rips is built using our HHR core component, the fastest rip core in the world. We then pass the continuous tone images to a number of parallel screeners using our ScreenPro core, the fastest screen engine on the market. It's then packed and streamed to the electronics. The scheduler is a key component as it manages all of the output from the massively parallel components. So the output from these rips can arrive out of order, which doesn't matter too much when you rip into disk. If you're going direct, you have to put the images back in order before going to the electronics. Also, if the rip is going too fast, then you could get your memory filled up, so you could need to back off that part of the pipeline until the press is ready to take data again. On the left here, I wanted to highlight that we're working with proactive technologies to build the fastest PCs using bleeding edge CPUs, RAM, and other components. In terms of specifics, you can see here an example of the speed we're able to achieve on an Intel i9 based desktop. So we're not targeting expensive Xeon servers, for example. So that's 36 logical cores running a single color job at 1200 by 600 DPI at 1000 feet per minute and 20 inches wide. So we've seen the architecture, but how might you actually control Harlequin Direct? Well, Harlequin Direct is supplied with an example front end called the Press Operator Controller, or POC. The POC is a press operator user interface that connects to one or more Harlequin Directs and manages the submission of jobs. It also demonstrates how to control and get status information back from multiple Harlequin Directs. We supply a pre-built Microsoft Windows version of POC to help you get started, and the source code in C# so that you can develop your own version. The POC can connect to both Windows and Linux version of Harlequin Direct. So not sure how well you can make out the screenshot here, but there's 3 queues and you've got the completed queue over here. So jobs enter the waiting queue, they get added to the print queue, and then when they've finished, back in the completed, you can drag them over again. It's really worth seeing a demo of this, and if you contact us after, then we should be able to share one with you. Okay, so we've seen the POC. Let's look at our model for supporting multiple color bars. So that's based on adding more Harlequin Directs. Here we have one PC with one Harlequin Direct per color. Adding print bars for extended gamut is as simple as adding one Harlequin Direct per color bar. Adding duplex can be achieved by adding a Harlequin Direct per side per color bar. As mentioned on the previous slide, the Press Operator Controller is supplied to control multiple Harlequin Directs and manage job queues. As it comes with the source code, you can add panels which collect data back from the press or interact with PLCs or other press-specific functionality. Okay, so now let's take a look at all the features and benefits of Harlequin Direct, the ultra-high data rate, massively scalable RIP solution. So the scalability comes from exploiting the multiple cores and architecting to use multiple PCs. So we've seen some diagrams of that already. Start printing as soon as you have the PDFs. Other solutions require ripping to huge image stores ahead of printing to keep up with higher speed and high resolution devices. However, it means you have a delay between receiving the PDF job and beginning to print. Harlequin Direct can begin printing as soon as the first page has been ripped. The first page out is practically instant, whereas those solutions built on raster stores can wait hours when the job has millions of pages before starting to print. Harlequin Direct has been designed to fit any workflow and integrate with any electronics. As we just saw, it includes the Press Operator Controller user interface for configuring and managing your Harlequin Direct instances and submission of jobs. We're continuously adding new features to this ourselves, but as you will receive the source code, you could add bespoke features for your customers and, of course, your own branding. With Harlequin in the name, it should be no surprise that it includes Harlequin Color Pro in-rip color management for accurate, consistent, and predictable color reproduction for a wide range of workflows. It provides full support for industry standard ICC profiles, including V4 and device link, so you can chain multiple transforms together for optimal management of all color on your press. It also includes Harlequin Vary data, which greatly accelerates the printing of zone variable data jobs that were saved either as PDF VT or as regular PDF. So the variable data zones can contain text, barcodes, and images. All the content outside of the variable data zones is static and can be ripped once, whilst the data in the variable data zones is ripped for every page. This greatly reduces the PC hardware required to rip the zone variable data PDF and keep up with the printer. As with ScreenPro Direct, it has print flat and access to a custom screen design service. It also supports Meteor Nozzle Fix when used with Meteor Inkjet electronics. Again, as with ScreenPro Direct, it is cross-platform with Windows 10, IoT, and Linux. At the end here, I've highlighted the configurability. You may wish to have one color per PC, or perhaps 2, 4, or 8, depending on how fast you want to drive your press, or how challenging your PDFs are to rip, which leads nicely on to The third of our products, Streamline Direct. One of the challenges we mentioned earlier was being able to achieve predictability in a direct solution. Not all PDFs are created the same. So if you can't control the sources of PDFs, they could vary massively in complexity and affect the ripping speed. Streamline Direct will check each PDF, allowing you to respond to any that are likely to slow your device down. As the name implies, the main response would be to streamline any problem PDF so you can achieve the same output quality while maximizing your device speed. Additionally, if your market requires non-PDF formats, Streamline Direct can be used to convert many formats to print-ready PDFs. Let's take a look at how this works. Streamline Direct is an optional component that can analyze a PDF's job structure and content using the result to predict the linear print speed achievable by Harlequin Direct. It uses intimate knowledge of the specific Harlequin Direct setup and PC to get an accurate prediction. If the predicted speed is lower than required, the press operator can do one of the following. So if the press supports it, they could slow down the press for that specific job. Or it could suggest the job is pre-ripped to continuous tone and then screen directly to the electronics. So this is a feature of the POC, which we call night mode. So you would submit PDFs and get the contone images out night mode. And then in day mode, you would send those through and they'd be screened directly to the electronics at ultra high speed. Most commonly though, you can optimize or streamline the job with using deep knowledge of the Harlequin rip to a faster job with the same output quality. Finally, Streamline Direct can convert from non-PDF jobs formats like IJPDS. To summarize then, Streamline Direct analyzes and optimizes print jobs for achieving predictable ultra-high data rates. Two PDFs can look identical when printed and viewed, but they can vary a huge amount in structure and content. To ensure that Harlequin Direct can keep up with the printer, you either need to control the creation of the PDFs, for example, using hybrid software steps, or you need a component that can look at each PDF job and predict the speed you will get before it's committed to a print run. As mentioned on the previous slide, Streamline Direct can choose what to do based on the prediction of achievable speed. When streamlining, Streamline Direct examines the structures of the PDF, employing specific strategies for different object types. These strategies will reduce the file complexity and enhance Harlequin Direct efficiency. Streamline Direct is the only job preprocessor that knows Harlequin Direct inside out. We've got the source for both and the experts that work on them in-house. So using insider knowledge enables Streamline Direct to target specific improvements that increase the data rates that Harlequin Direct can achieve. So streamlining a file will eliminate duplicate fonts and merge font subsets, merge and intelligently downsample duplicate images, eliminate duplicate resources and X objects, remove print redundant data such as user metadata, annotations, bookmarks, links, comments, and thumbnails, compress content streams and data structures and optionally flatten layers, discard empty X objects and repair incorrect references, and most significantly, it can tag PDF objects with Harlequin Direct defined hints, enabling the RIP to skip time-consuming in-RIP content analysis. It also includes basic pre-flights such as looking for non-embedded fonts, and you can import from multiple PDLs. And it's cross-platform like our other products. If you want to understand more about the PDF features that can impact performance for variable data jobs, then we really recommend Martin Bailey's Full Speed Ahead webinar on May the 13th at 3 p.m. BST. Okay, so we know all about the three products now. This diagram is showing the complete software pipeline that includes them, but also covers the electronics and creation of PDFs. So on the right, we have Meteor, who we have already talked about, but it's worth emphasizing that having experts in the global graphics group who work with the technology that's closest to the press means we can benefit from their insights on a daily basis if necessary. And it works both ways, of course. On the left, we have technologies from hybrid software that are combined with Direct to form fundamentals for label and packaging. If an OEM is building a label and packaging press, then they can add workflow support in front of Direct with Cloudflow Direct for connecting into variable data sources and assembling print-ready PDFs designed to work perfectly with Harlequin Direct. They can use Steps, an award-winning composition tool. This gives an OEM delivering label and packaging solutions the full solution. I'd like to now summarize the key advantages that Going Direct will give you. So the press is not limited as data rates increase. We've seen how they're increasing, and it's only going to keep continuing to go up. The press doesn't need to be re-engineered to meet future requirements. Existing press models can be retrofitted with Direct. So you would start with ScreenPro Direct. So one customer saw a 50% improvement in time to rip using ScreenPro Direct. You can get presses to market quicker with lower total bill of materials. So you have the option to use lower performance PC hardware for less demanding jobs. It's easy to add spot colors with one PC per color bar. It's easy to add duplex support, one PC per side. You can have different output per color bar, so 2-bit for black and 1-bit for others, or different resolution, e.g. low resolution on white and varnished color bars. Finally, Direct is designed to be part of a fully automated print solution. Feedback from quality systems can modify in real time how a job is ripped or screened. And these are only the advantages for you. Your customers will enjoy many more if you choose to go direct, and we're looking forward to working with you to make that happen. So in summary then, Direct unlocks the potential of digital presses by driving print jobs, PDF or TIFF, directly to the printhead electronics without touching disk at ultra-high data rates. Direct is key to a future-proof, fully automated and intelligent print solution aimed at solving the hardest challenge of fully variable content. Global Graphics is uniquely positioned to deliver Direct because we have all of the core components required in-house and can create a tightly integrated product line. Direct is available now. For more information, please visit globalgraphics.com/direct. That's the end of the presentation. We will now start answering your questions. Thank you very much.
Thank you, Ian. We would welcome any questions that you may have using the Q&A feature or the chat feature. Currently, there are no questions, Ian, so you must have done a very thorough job.
Wow, okay.
In your presentation, for which
That's great to hear.
unless I see some questions pop up, I think that we can probably complete the call. And oh no, I do have a question.
Give people a chance. I guess they've been making notes as
Yes,
we go.
indeed.
I did go pretty swiftly.
Yeah, there's a lot of content in here, isn't there? So question is, I'm developing software for generating fully variable PDF from data, i.e. no static parts. Can I use ScreenPro Direct as a pre-flight engine to optimize my software for printing speed of the PDF output?
If you're creating PDFs, then I guess some of the names are quite similar, aren't they? But it would be Streamlined Direct that would optimize your PDF, but it would be optimizing it to go through Harlequin Direct using the insider knowledge. This might be one of those situations where it's worth tuning into Martin Bailey's webinar next week. Maybe I should hand over to Martin on this.
I think you've answered the question. The key component out of this whole family that would be useful for people doing composition software for variable data and for every page different would be Streamline Direct, because that is, half its goal is to tell you how fast that or whether a particular job could achieve engine speed on a particular engine. Obviously, that's engine specific. If you think about the table that Ian showed on of the data rates, there's a big difference between a narrow web 4-color label press and some of the corrugated and decor presses that we're working with people on at the moment. But yes, that would be the component for looking at essentially pre-flighting.
Thank you. I hope
Okay,
that answers
yeah,
the question
yes.
fully. Yeah. Any more? I'll just slow down a little bit so that people can submit their questions if they have any others.
Okay.
In the meantime, just remind you, as Ian has said, and as you can see on the screen, there's more information on our website at globalgraphics.com/direct. Meanwhile, we have another question, so thank you for that. The questioner asks, how do you get the large amounts of data from the farm rip to the printing system?
Okay, so the farm rip, as in it, you've just ripped the continuous tone. So in our case, we're using the shared memory. So the rip will rip directly into shared memory that then is screened from there, and that PC will be connected to the electronics. So you could have some Meteor boards hooked up to that particular PC, and then those are connected to the press. This actually goes beyond the extent of my knowledge, the final press part, but maybe Eric can take over at this point. He's muted at the moment. But the flow all the way from ripping to the Meteor boards or whichever boards you've hooked up to is all on the same PC. That's the model we use.
Yeah, so the data that goes from the farm rips to the screener is, as Ian said, via shared memory. So that's all within a single PC, the Harlequin Direct PC. The data that goes from the Harlequin Direct PC to electronics depends on how the electronics carries that data. Quite often that's Ethernet or multiple Ethernet cables, depending on what sort of speed that you're trying to run at. But it could also be other kinds of data cabling, so things like other kinds of data cabling that you can put in place. So, but most of the time it's Ethernet that's transmitting the information from the PC through to the electronics.
I hope that answers that question. A couple more have come in. So a questioner asks, how long could it take to go from ScreenPro Core to ScreenPro Direct using different electronics than Meteor electronics?
Well, it depends which electronics, because we might already support the one you're referring to. But if not, back on the ScreenPro Direct slide, it wasn't written on there, but I mentioned that it takes about 20 days with our breakthrough service to create a output plugin for ScreenPro Direct to support a new type of electronics. So that's 20 working days. And that would be a breakthrough project, which is fully recoverable against license fees. So effectively free in the end. Hopefully that's sufficient.
Hopefully
answer.
that's answered that one, yeah.
Yeah, get in touch, definitely. If you're interested, we'll be able to talk about it more.
How
we may already support that one.
How should people get in touch with us directly, Ian?
Well, I think going to the website and then there should be a contact us button. You can download the brochures and then go from there.
And then hit the contact us
I would say,
button.
yeah, see the website first, because there's a chance that we've already answered the question on there.
Right.
But yeah, there's contact us from there.
Great. Another question from somebody who is currently using Mako for rendering PDFs. And the question is Streamline Direct based on Mako? And does this mean that we also can use Mako to optimize and check PDFs before we process them? Maybe this is a question to Martin. That's what the questioner says. Maybe
well Mako is definitely inside Streamline Direct, Mako technology. But as for the rest, yeah, I think let's hand over to Martin.
Well, the Streamline Direct is specifically designed to optimize jobs for Harlequin because we've got a lot more optimizations for very high-speed usage in Harlequin. But there are certainly some of the optimizations that you can do with Streamline Direct that would be valuable for rendering in Mako. whether it makes sense to do that as two separate passes, or whether it makes sense to do things like perhaps downsampling ridiculously high resolution images to something more appropriate. As part of the rendering process, I would have to hand that over to the Mako team, but obviously you're in touch with them already, and it's probably something to explore a bit more with David Stevenson and the rest of the Mako team.
Thanks, Martin. So a couple of other points here. Do we have a list of electronic boards supported at present apart from Meteor?
Well, I don't know if some of these are top secret confidential, so I wouldn't want to risk saying anything that I shouldn't, because some of our customers are working on products that they haven't announced yet.
Yeah.
So yeah, we shouldn't mention here, but someone a bit
you
higher
said
up than
earlier,
me would know. Yeah.
I think you said earlier, Ian, that it isn't just Meteor that
Yes.
we support. There are other vendors too.
Yeah. I don't want to answer on the spot and say something I shouldn't. So yeah, it's best to follow it up, and the appropriate person, the appropriate level will be able to give an answer.
So ask the question on the info button on the website, on the web page, perhaps.
Yeah.
It's always painful when people ask questions about stuff that we've done or we're currently doing, and it always feels very weak for us to say, I'm sorry, I can't tell you that. But sometimes the confidentiality agreements we have in place mean that we can't talk about all the great stuff we've done, which is frustrating as anything. But yeah, if you contact us directly, we can work our way around the question without answering it directly, if that makes sense.
For a number of reasons, it's frustrating that Drupal was cancelled, because some of our customers would have been showing off their systems there.
Yes. Yes, good point. Okay, so now I've got a couple of people who've asked if they can sign up for the next webinar. So I don't know if that means the next one on the same topic, which means this afternoon.
I think they mean Martin's.
Or our webinar series. And also someone else who asks whether we'll be sending out the presentation. So I suppose the easiest thing is that we could contact people who have attended and answer both questions in an email.
That's a good idea. Follow-up email. This will be shared. I don't know if it'll be shared to the people who watched or shared on Twitter or wherever, LinkedIn and so on. But it will be shared. If you want to watch it again, then definitely.
We'll send a link
it's been
to
recorded. Yeah,
recording.
I'm even recording this part. Yeah.
Yeah.
We might chop this off. I don't know.
We'll send around a link to the recording. I think that's the easiest thing to do for everybody. And in doing so, we'll let you know if you are interested in Martin's webinar next week about how to optimize variable data PDF files. Then we'll put the information in the same email for you. And I think that may be it.
Okay,
so
well, I mean,
unless
if anyone
something
has,
drops in.
If anyone has any other questions, then of course, yeah, go direct to the Direct website and contact us direct through there. Because some questions can't be answered very well on the spot anyway, can they? So, you know, we might need a discussion or a chat and so
Exactly.
on. So, yeah, excellent.
Yeah. Thanks very much, everybody, for your participation today. And we hope to speak to you soon. Thank you.
Thank
Bye-bye.
you. Bye.
Bye.